So in the last video I showed how to trace through and find a bad connection, and in this video I'm going to show how easy it is to fix it. So we know that input number 2, this one here, is dead. This unit is only peaking around 3.8, it should be around the 6-ish, it's a bit hard to see in the sun. It's fluctuating a little bit because there's lots of clouds going overhead today. So we can quickly test the voltages again, just to see. So using my multimeter and my probes, a bit tricky one-handed, we can touch the screw terminals. So input number 1 is around 220-ish volts. Input number 3, 220-ish, 220-ish volts. And input number 2, if I can just wedge it in, is showing nothing. So input number 2 is dead. Again, another way to confirm, if you keep flicking off the suspected dead input, nothing will change. Flick off a good input and you'll see it half, drop by whatever. So we already identified the bad connection that's on this circuit, which is this one here, all melted and twisted. So I'm just going to swap this out. So all we need is, I decided to buy the proper crimp set because working in the field I haven't got access to all my tools, so it's better to have the proper one. This is a nice heavy duty unit. It's got the crimp for 6mm, 4mm and 2.5. My sites use 4mm cables. It's got a nice wire stripper and decent wire cutters, and it's got this guide as well which fits onto the side of the crimp so that I can plug in the metal parts and it'll automatically hold them in the right place. So sometimes when you're working around like a already installed unit, you're working one-handed sometimes holding things, so that's why I thought I might as well spend the extra little bit of money and get the proper set. This set was only 7,000 yen, and it was like 4,000 yen for a cheaper version of the crimp, so I decided to buy the proper one. It's a good beefy unit. Anyway, these are the 3-meter bypass cables which I had last time and I was testing with, and I realized that I needed a few extra cables last time. So I bought these 6-meter extension cables and these 20-meter extension cables, and then I cut 1 meter off each of the 6-meter cables, and I made my trailing little dongles. So that way, now if I want to test like a extension cable, and I think one of these cables is bad, which it was, I can unplug this, put this into that terminal, and then I have this trailing socket, so I can plug my 20-meter extension in and then test anything I like. So I think you get the idea. So all of this wasn't much, all in 20,000 yen, 100 quid. Oh yeah, and a box of the MC4 connectors. They all seem to come with these plastic spanners, but I'm finding these metal ones to work much better. So these connectors, I'm not sure if they're good quality or bad quality. They seem okay to me. The watertight seal seems good. Yeah, so these are rated up to 1,000 volts, and I saw that there's some available rated up to 1,500 volts. But I know that my arrays of panels only tend to be handling around 250 volts max, and the current that these are rated for is more than enough, so they seem okay to me. So all I'm going to do now, cut this off and swap out the connector. So this is pretty simple stuff. Just trace through your cables and make sure you get your connectors the right way round. So this cable here marked with the green tape is the negative cable coming from my panel, which will be the negative side of the connector, and the extension cable going back to my power con will be the positive side of the connector. So the positive is the male side and the negative is the female side. So now you can just cut this off and connect these on. So I'll record myself doing it and then put it on a time lapse. So that's it. Here's my new cable connected together. So let's go back now and flip that breaker on the power con and see what we have. So we're back at the power con now. Input number 1 and input number 3, our two good circuits, are on, and we're currently reading up to around 4, so 3.9 to 4. So let's flick on circuit number 2, the one we just repaired, and now we're up to 5.9 and 6. And just for fun, let's do voltage readings. So input number 1 is 220 plus volts. Input number 2, this is the one that we just repaired, is 220-ish volts, 230. And then input number 3, 220, 230 volts. So there we go. Now this power unit is back up to normal capacity. You can see, look, 5.9 to 6. Again, it's fluctuating a bit because it's a cloudy day today. So there we go. This one failed connector was causing all those troubles, and it was a super easy fix. So it was worth investing in the proper tool set. I'll be needing this again over the years. I've got 3 sites. This box of connectors was only 2,500 yen, and on the video I even used the spanners that came with it, just to show how easy it is, although I'm finding these metal ones much better. So yeah, I kind of regret not sorting this out sooner. I've always suspected that this site was running a little bit low, but it's only after I did all the work with the ground sheets and the concrete and the cages that I decided to investigate and sort out the last little bit of the puzzle. So I think that this has probably been costing me somewhere between 5,000 yen and 7,000 yen a month, because that one array was offline, which over a couple of years it could be anywhere between 150,000 yen to 200,000 yen lost income, which is on me. I should have sorted this out sooner, so I'm kicking myself for that. But yeah, there we go. That's how easy it is to fix, and how cheap it is. 20,000 yen for some spare cables and the proper tools, and some replacement connectors, and now I can easily analyze all of my 3 sites and sort out any problems I have. Cheers for now.